All right, so we're adding and subtracting unlike fractions. How does adding and subtracting unlike fractions compare to adding like fractions? All right, so a survey was given, and then we asked, how do we use our cell phones? Looked like 3/8 of the people enjoy taking pictures, 1/3 of the people like to play games, and 7/24 enjoy texting and calling. I want to know what fraction of owners use their cell phones to take pictures and to text or call, so the red and the blue together. So I need to find out what I want to add. So I'm going to add taking pictures, the red, and then the text and calling portion. So 3/8 plus 7/24. But I can't just add straight across and end up with 10/32. That would be a problem. Have to have a common denominator. So that means I look at 8 and 24. I did this to the side over here. I wrote multiples of 8 and then 24, and I found out that, wait, 24 is the common denominator. So this first fraction, I had to multiply both the top and bottom by 3. To get 9/24. The other one I kept it the same, and now that we have the common denominator, we can add across and get 16/24. But I'm not done. I need to then reduce if possible. So I'm going to reduce by dividing both by 8, and I get 2/3. So 2/3 of the people surveyed like to take pictures and or text and call. Question to you in this particular, I use this to kind of just show you adding unlike fractions, but could you have found this answer in a faster way? Take a look at the problem, see if you can. Here's another example. Sarah's making a 2-layer chocolate and vanilla cake. Yum. The first part of the recipe asks for 2/5 cups of oil. The second part asks for 1/3 cup of oil. So that's kind of what the recipe looks like. How much total oil will she need? All right, so we got to figure out, what am I adding? Well, I'm going to add the total oil for the chocolate and the total oil for the vanilla, and that should give me the total oil I need for both of them. So those two numbers are going to be 2/5 and 1/3 cups of oil. But can't add it as it is. I have to find, again, a common denominator. So take a look at the work I've done. Let's see, 2/5, 1/3, 15 is the common denominator. I multiplied the first by 3, so this also gets multiplied by 3. And the second fraction by 5, so both the top and bottom, numerator and denominator, both by 5. So now I notice the denominators are the same. I can add my numerator, 11/15. Can I reduce it? I cannot. 11/15, can't make it any smaller, so that's what it is. My next question to you is, wait, what if Sarah has a total of 1 1/3 cup of oil? How much oil does she have left over? Well, we know she has enough to make that because this needs less than 1, so she has more than that. How do we figure that out? Well, we're going to have to subtract the total oil, which is here, and subtract the oil that we need, which is here, and figure out what we have left. So I wrote some step-by-step instructions for this. First step is I would change this mixed number into an improper fraction. Okay, it's going to make my life a little easier. Then I'm going to find a common denominator, which turned out to be 15. Multiply this by 5 to get there, and keep this the same to get there. Now I can subtract, and I end up with 9/15. Can I reduce that? I sure can. Divide both by 3, and I get 3/5 of a cup left over. That's it. That's how you find your answer when you're subtracting unlike fractions. Let's get some practice just number crunching. All right, so 4/5 minus 1/6. Look, I got to find a common denominator. I can do that. I found out it's 30. Means I multiply the first by 6, the second by 5. So I do that. I get my new numbers. Notice I'm multiplying both the top and the bottom by that factor. Subtract if possible, subtract. I can do that. And then reduce if possible. So I get 19/30, but I cannot reduce because 19 is prime, so that's not going to work out for me. All right, let's do another problem. This time's a little bit different. Watch out. I've got this parenthesis here. So first I want to do is simplify the parenthesis if possible. So I can get rid of this parenthesis by noticing that a negative in front is going to change this. This is the opposite of the negative 1/4. So that is positive 1/4. Now I just follow along the same steps as before. Common denominator, sure, that's 20. Multiply this one by 2 to get there, and 5 to the second one. Once I have a common denominator and I change both the numerator and denominator, I can add. So I add, that's 11/20, and then reduce if possible, which I cannot, and that's it. Something a little more challenging, you ask? Perfect. So I've got 3 fractions this time. Oh my gosh. It's all right. Same steps. No parentheses. Don't need to do anything with that, but I need to find a common denominator of all 3. Can you guess what that is? That's right. It is 30. So this first one gets multiplied by 10. The second one gets multiplied by 6. And the last one by 3. As long as you multiply the top and the bottom, then it's equivalent fractions. Okay, now I can go ahead and add the numerators. I do that. And at this point, you can kind of do one of two ways. You can either reduce and then change it to a mixed number, or go a mixed number and then reduce. I decided to change it to a mixed number first, which is 1 and 14/30, and then reduce it, which is 1 and 7/15. So I got a little carried away with my drawing this one, but this is the last question. Find the error that Homer has made. Here he's thinking very hard, and he's like, what? I don't get it. Why is it not 2/7? Figure it out and do it correctly for him. All right, come with questions tomorrow, and that's it for today.